So here we are, our last session here for the Viper implementation on distance learning alpha. First of all, I want to say thank you all for taking part in this, and I hope that you've actually learned and walked away with some information that will be valuable to you in your regular work. This session, we're going to be focused on a number of things, really kind of the higher order operations of Viper that include things such as the object on file and the ability to deal with data protection services. And that's going to be a little different too, because we're used to seeing things such as recover point and understanding that that's what we call data protection. But in Viper, we also consider vplex to be a data protection option. So that's quite a difference. We're going to take a look at a few things right now on dealing with the way that the object services work in Viper. The Viper Object Data Services is really similar to the Amazon S3 model, but Viper adds extensions such as byte range updates, atomic append, rich ACLs, etc. On top of the Object Data Services, Viper includes several API heads including Amazon S3, OpenStack Swift, and our own EMC Atmos. The Viper Object Data Service uses the same configuration and provisioning access provided by this Viper controller. A storage admin defines a virtual storage array and configures virtual storage pools. The Object Data Service supports physical segmentation of the objects. An object virtual storage pool can write to multiple physically separate arrays. In the example shown here, one pool is writing to one virtual storage array that is writing to multiple commodity arrays. The other virtual object storage pool is writing to a different virtual array and is writing to three distinct physical file arrays. In addition to physical segregation, buckets provide logical segregation within the object store. Just like in S3, a user can create buckets which logically segregate applications or sets of data. The actual processing of objects is done by a virtual set of data nodes. The nodes are simply VMs with process object requests and feature a scale-out architecture to allow for full failover between the nodes. Since they're VMs, they're easy to deploy. Another important differentiator is the distributed index is used to track data locations. Rather than maintaining a separate index in a database, which can't scale well, the index is located on the actual array in the container. So this way, the index can scale massively, be geo-distributed, and it removes the idea of it being a key bottleneck in existing object storage platforms. So the Viper Object Data Service now can locate objects on a massive scale, geo-distributed, much faster than the competition can. Organizations using the Viper Object Data Service can extend object storage to existing file-based storage such as EMC VNX or Isilon, or third-party arrays such as NetApp FAS. A bucket of objects can be dynamically toggled between the three different access modes of object, file, and then dual mode, which allows read access to either the object or the file. So in this example, what we see is a next-gen video sharing web application that ingests objects into a high latency object store and then exposes the uploaded video content. But before exposing that content, video processing application that's written to a lower latency file storage platform such as Isilon needs to perform analytics, watermarking, etc. before posting back to the web. So in this case, the organization has to copy all the uploaded data to a file-based storage location, do that work, and then copy it back to the object store. With Viper, though, all these objects can be ingested via the REST API directly into the Isilon. The administrator can now simply just toggle it to file mode, mount the NFS, perform the operations, and then save the files, and then toggle it back to object mode. The data never has to be moved or copied. Only one storage platform is required. So as we go through our last session here, make sure to put some time in and put in your final discussions. It's been some great conversations that have been taking place up there between you and also with myself involved. And I think that that's a real key in any kind of training, is where you have a chance to talk to each other as well as to the instructor. We also have the continuing work within our projects, and I've suggested using a kind of a new tool here called Prezi to do that. But also take the time to go through the glossary that we've been building throughout the entire course. Finally, do me the personal favor of taking a few minutes and completing the evaluation on this learning platform. One of the key goals for me was to be able to determine whether this is some way that we can use distance learning and asynchronous learning to try and get information out to you in a faster and easier to use model. Thanks again, and I hope to be seeing you soon.